Example 1. The point P, 3, 4 is on the terminal arm of an angle in standard position. Determine the distance from R to the origin, distance R from the origin to point P. Determine the primary trigonometric ratios of theta, and determine the measures of theta to the nearest degree. Okay, so a lot of things are going on in this question. We're talking about the primary trigonometric ratios. Guys, this is just what you did with those worksheets. That's just sine, theta, cos, theta, and tan theta. So SOHCAHTOA. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is OA, opposite over adjacent. Another thing, standard position. That's just, let me just draw this. First things first, it's always good to draw a little bit of a picture. Point 3, 4. Okay, so the point is right here. This is in standard position, okay? Because we have our x and our y. Okay, it's going from and we know that theta is going from this x-axis to here. So I'm just going to label this point 3, 4. All right, so first things first, determine the distance r. Okay, so this guy is here, is r, from the origin to point P, which I should have labeled here. Guys, we're just going to use Pythagorean theorem. This is 3, this is 4. The way we find r is 4 squared plus 3 squared equals r squared. 16 plus 9 equals r squared. 25 equals r squared. R equals 5. We're going to get to the point where r equals plus or minus 5, but since we're in the first quadrant, we're not going to worry about that negative quite yet, okay? Usually, like I would say, it's going to be positive or a negative 5 when we have a variable out here, but just for this section right here, let's just keep it at r equals 5, even though, in all honesty, guys, it could actually be both. Okay, so the distance, and oh yeah, that's another thing. We're just looking for the distance, so we're looking for the magnitude, which can only be positive. So r equals 5. B, determine the primary trigonometric ratios of sine, cosine, tan, sine, cosine, and tan. Now this is the part that's a little bit tricky for a lot of people. This right here is our theta. This is right here is the angles that we're going for. Not here, okay? No. Here? No, it's this guy right here from the x-axis up to the terminal arm, okay? Not from the y-axis to the terminal arm, not some crazy thing here, from the x-axis to the terminal arm. So then knowing that, let's just write what our opposite, adjacent, and hypotenuse is. The length that's opposite is this, opposite. The length that's beside it is this, adjacent. And this guy right here is our hypotenuse. Sometimes people find it helpful if they label the hypotenuse first, because sometimes it's like, what's hypotenuse? What's adjacent? I don't know. Okay? So, sine theta is opposite over hypotenuse, 4 over 5. Cos theta is adjacent over hypotenuse. Adjacent is 3 over 5. And tan, crazy tan. You'll notice that sine and cosine can never be greater than 1. But tan can be whatever it wants to be. So tan theta is opposite over adjacent, which is 4 over 3. That's 1.3333333333 going on forever. Crazy tan. Love that guy. Question number C. Determine the measure of theta. Determine the measure of this this right here in degrees. Now guys, save yourself a lot of headache. Right now, I want you to go to your calculator and make sure that it is set to degrees. This whole unit is going to be really hard for you if you have it set in radians, or what the engineers like to do, gradians. Okay, so just a little side note, degrees split the circle into 360. Those crazy engineers, they take the circle and split it into 300. Those are gradians. Radians you'll learn about next year. They're beautiful and terrifying and fraction filled. It's going to be really great for you next year. I'm not being sarcastic. I really like radians. Okay, so after all of that, determine the measure of theta to the nearest degree. All we have to do is use our inverse function. So I can take sine sine to the negative 1, it's sine inverse, okay, of 4 over 5, which is going to give me the exact same answer as cos inverse to the 3 over 5, which is going to give me the exact same answer as, you bet, tan inverse to the 4 over 3. And what does that equal, folks? When you punch any one of those things into the calculator, it equals approximately, because it's going to be like crazy decimals, but it's going to be approximately 53 degrees. Don't be silly and leave this degree sign out. Just don't do it. Whenever you have something in degrees, make sure that you always put the degree sign in, because in pre-calculus we don't have to use our units very much, but you know, when we can't give something a unit, let's step up and do it. That's it for the videos. Have a great weekend.